So sometimes when we're given an equation or a relation, it depends on what the equation is, and you might have to actually restrict what your x values are within that equation. We can't just assume that x can be anything. So that's what we're going to kind of talk about here. So there's three different things, or actually two different things, the third one being them together, that you guys have to pay attention for when you're looking at domain. The first one is fractions. And you guys know this, you probably just didn't really ever think about it specifically. When you have a fraction, your denominator can't be equal to 0, right? Because you can't divide by 0. So when you're trying to find a domain restriction, all you guys do is set the denominator equal to not 0, because we don't want the denominator to be 0. And then we find what the domain restriction would be. So like if we look at this first example here, g of x equals 2x over 5x plus 2. The denominator is 5x plus 2. So that is what we don't want to be 0. So you guys just solve for this. And we don't want x to be then negative 2/5. So instead of just saying we don't want x or x shouldn't be negative 2/5, we're going to write it in interval notation. So we're going to say x can be any single value from negative infinity to positive infinity except that value of negative 2/5. So how we note that is we say negative infinity to negative 2/5, and then we skip over, I'm going to kind of squeeze that in there, skip over that value. That's what the u is. It's showing that there's a gap there. So it's coming all the way up to negative 2/5 from the left, from those negative values, skipping over it, and then continuing to positive infinity. So you need to first figure out what your x can't be, and then write that in interval notation for the domain. So when you have a fraction, the domain needs to be restricted to what value of x would make that denominator 0. So you guys need to solve for what that would be. The second domain restriction you guys need to be aware of is if you have an even root radical. So remember, your even roots are if you have like a square root, a fourth root, a sixth root. Because when we're talking about domain, we really want to just include those real values. So the expression underneath your radical shouldn't be or can't be negative, because we only want to operate with real numbers. So for even root radicals, you set the expression underneath the radical to be greater than or equal to 0. It is allowed to be 0, but it has to be 0 or greater, so that we only include those positive values. So if you look at y equals 3 minus the square root of x plus 5, we really could care less about that 3 minus on the outside. We just care that that x plus 5, that expression that's underneath here, to make sure that's greater than or equal to 0. And you guys can probably do that in your head. What value would that be? Negative 5. So x needs to be every value, or any value, greater than or equal to negative 5. So that would be negative 5 and higher or greater. So that would be in the right direction. So we would say negative 5 to positive infinity. That could be any of our x values. And because we're including it with that line, it's going to be a bracket. Okay, so we've talked about fractions and even root radicals. So what happens if you have them in the same problem? You have to pay attention to both of them. So in this case, your x value has to be greater than or equal to 0, because there's an even root in the problem, but then it also can't have the expression of whatever's in the denominator equal to 0. So for you guys, what the case is always going to be is that it's going to be from 0 and on. So like if we look at this, 3x squared can't be equal to 0. So you guys would divide by 3, get 0, take the square root. X can't be 0. But if you solve for 2x being greater than or equal to 0, x would be greater than or equal to 0. So this one says, oh, well, we could include 0 as long as that wouldn't make it negative. But because of the fraction, that one isn't including 0. So instead of, like over here, you had the number with the bracket. Instead of including 0, we're going to say from 0 to positive infinity, not including 0. So that would be like 0.00000, like 1.00, as many zeros as you can think, 0.1. You just can't have 0 because it's also a fraction. So, we'll talk about that in the lesson. You won't have really too many of those within your lesson, but it is something to be paying attention to. So, I guess then what all this means, if those are the only two things with domain restrictions, that fraction and even root radical, those are the only things with domain restrictions. If your equation, your relation, whatever it is you're doing, doesn't have either one of those, then there are no domain restrictions. So if you have no even root and no fraction, there's no domain restrictions. It's just negative to positive infinity. So that means even if you had a odd root, they would still be okay. It's just those even roots and those fractions that have some sort of domain restriction that you would need to figure out. If it doesn't have one of those, no problems, no restrictions. Negative to positive infinity, x can be anything. So when you're doing these, you just need to pay attention. Does it have a fraction? Does it have an even root that I need to solve for and find what x value needs to be excluded as the restriction for its domain of that equation?